Hi guys, and welcome to another General Chemistry 2 video, brought to you by Group 4 Zinc of Grade 12 unit. Now, we're going to discuss about the arithmetic of chemical solutions, specifically molarity and molality. Let's go!
Molarity. Molarity is the ratio of the amount of moles to the volume of solution in liters. It is represented with the capital letter M and expressed with this formula. M equals N all over capital letter V, wherein M denotes the molarity at moles per liter. N is the moles of the solute, and V as the volume of the solution at liters. Keep in mind that we strictly use the units mole per L, mole, and L. Convert the other units to these units in order to meet the correct molarity of the solution.
Let's look into this example. What is the molarity of a solution if 5.0 mole of solute is dissolved in a 2.0 liter solution? Our given are N equals 5.0 mole and V equals 2.0 liters. What we need to find is the molarity of N. By using our formula M equals N over V, we substitute as 5.0 mole all over 2.0 liters. Now we arrived at 2.5 m of the solution.
Let's try this one. How many milliliters of a 0.625 molarity KOH or potassium hydroxide solution would contain 0.0250 moles of KOH? Our given are 0.625 molarity KOH and 0.0250 moles of KOH. What we need to find is the volume at milliliters. By deriving our formula, we now get V is equals to N all over M, and we substitute the values as 0.0250 moles all over 0.625 moles over liters of KOH. We cancel our moles and leave behind liters as our main unit. By division, we now get 0.04 liters of KOH. Since we need to find milliliters instead of liters, we now have to make a ratio of 2 by 1000 ml all over 1 liter. By canceling the liter unit, we arrive in milliliters as we multiply this. Now, we get 40 milliliters of KOH. And that's our final answer.
How about another one? What is the mass in grams of ammonium chloride present in 50.0 milliliters of a 0.800 molarity of ammonium chloride solution? Our given are 50.0 milliliters or 0.050 liters as we converted initially by multiplying it with a ratio of 1 liter all over 1000 milliliters, but also having 0.800 molarity of an ammonium chloride solution. What we need to find is its mass in grams. We know for the very fact that we can have a factor of moles in grams with a molar mass of ammonium chloride, but we will get into that later. For now, we must derive the formula by finding moles at moles is equal to molarity times volume. By plugging in the values of 0.800 moles per liter multiplied to 0.050 liters, we cancel liters leaving behind the unit moles. Multiplying these values, we are able to get 0.04 moles of ammonium chloride. Now, since what we have are moles, we must convert it into grams with the use of the molar mass of ammonium chloride at 53.484 grams per mole. We can get this by adding the atomic masses and its corresponding coefficient if many. So what we know is 0.04 moles of ammonium chloride multiplied to the factor of 53.484 grams all over 1 mole of ammonium chloride. Canceling the mole units, leaving behind grams, we are able to get 2.139 grams of ammonium chloride. After tackling molarity, we now proceed to
Molality. In contrast to molarity, molality is ratio of the amount of moles to the mass of solvent in kilograms. It is expressed with the lowercase letter m and expressed with this formula. M equals NO over kilogram, wherein M denotes the molarity at moles per kilogram, N is the moles of the solute at mole, and kilograms, as where its unit is referred, the mass of the solvent at kilograms. Again, use the units mole per kilogram, mole, and kilogram. Convert other units to these units in order to meet the correct molality of the solution.
Let's look into this example. What is the molality when 0.500 mole is dissolved in 2.50 kilograms of solvent? R given is 0.500 moles of the solute and the 2.50 kilograms of solvent. Using our formula at molality is equal to moles of solute divided by mass of solvent in kilograms, and as we substitute these values, 0.500 moles all over 2.50 kilograms is 0.2 moles per kilograms, which will be our molality of the solution.
Okay, how about this? What mass of barium chloride is needed to dissolve in 1.2 kilograms of water to prepare 0.500 molality of barium chloride solution? R given are 1.2 kilograms of the water solvent and the 0.500 barium chloride solution's molality. Deriving from our formula as N equals kilograms times molality, we substitute them as 1.2 kilogram multiplied to 0.500 moles per kilogram, where we cancel out the kilograms, leaving behind moles as our unit. Thus, we get 0.600 moles of barium chloride. Now, we can convert moles to gram via the factor of the molar mass of barium chloride at 208.22 grams per mole. Multiplying this, we can cancel the mole units and condense into 124.93 grams of barium chloride.
In short, we have discussed a segment of arithmetic of chemical solutions. Molarity is the ratio of the amount of solute all over liters of solution with the unit of moles per liter. Its formula is capital M equals N over V. Molality is the ratio of the amount of solute all over kilograms of solvent with the unit of moles per kilogram, having our formula of lowercase m equals N over kg. Note that we must be prepped for our use of conversion factors and ratios for our solving of other units in regards with our calculations. That is all, and thank you for watching this video.